A very good day to you all, and a warm welcome to free webinar on Helipad Construction, a collaborative effort between Structural Design Institute, more commonly known as SDI, and our esteemed partner, Civil and Structural Engineering Consortium Private Limited. If this is your first time with us, SDI is an educational institution that has a lot in store for you. We specialize in engineering, covering areas such as design, construction, and software training. What sets us apart is our close affiliation with civil and structural engineering consultants, a name synonymous with excellence in the field, having worked on several iconic projects in Sri Lanka. At SDI, we are committed to the continuous professional development of engineers. So we offer CPT courses and events for those pursuing chartership or looking to enhance their skills. You can see a few of our ongoing and upcoming courses here. We are focused on structural analysis and design, architectural modeling, and even some courses focused on specialist topics. What sets us apart from our other similar organizations is our exceptional faculty, as our educators are all practicing engineers with extensive real-world experience, some of whom are even renowned in academia. We also offer a set of publications, including tall building guidelines for Sri Lanka and construction specifications for tall buildings in Sri Lanka, as shown on the screen, with more to come. These books encapsulate our team's wealth of experience, diving deep into design and construction specifics. I would like to also introduce our upcoming intensive course on state-of-the-art computer-aided analysis with Procon, which will be starting on the 5th of March and will be held for 4 consecutive Wednesdays from 7 p.m. to 9 p.m. The details regarding the course have been posted on our social media platforms. You can find the registration links from there. Before starting today's webinar, let me introduce our resource persons for today. The second webinar, Helipad Construction on Rooftop, will be conducted by 2 industry professionals, Engineer Shiromal Fernando and Engineer Retired Air Vice Marshal Udula Wijesinghe. Our first resource person, Engineer Shiromal Fernando, is the founder and Deputy Chairman of Civil and Structural Engineering Consultants Private Limited. Engineer Fernando is renowned for his exceptional contributions to engineering, particularly in dream of high-rise buildings. His impressive portfolio includes landmark projects such as the 350-meter Colombo Lotus Tower, the One Krish project, and the Cinema Life Waterfront Integrated Resort. His expertise extends beyond Sri Lanka with significant projects in various countries. Holding a BSc Engineering honors in Civil Engineering and an MPhil degree from the University of Moratuwa, he is a chartered engineer of the Institute of Engineers Sri Lanka. In addition to his professional accomplishments, Engineer Fernando demonstrates a deep commitment to educating young professionals within the construction industry. This dedication was the sole purpose behind his founding of the Structural Design Institute, where he continues to instill these principles within the organization. His dedication to nurturing the next generation of engineers extends to his role as resource person for educational sessions organized by IESL, SSESL, GBCSL, and various universities. Our second resource person for the day is retired Air Vice Marshal Engineer Udula Wijesinghe, who joined the Sri Lankan Air Force in 1990 and was commissioned as a pilot officer in civil engineering branch in 1992. He has held several key positions, including Director General Construction Engineering in the Air Force, overseeing critical infrastructure projects. A chartered civil engineer and a graduate of General Sir John Kotalawala Defence University, Mr. Wijesinghe's 32 years of distinguished service earned his numerous awards and commendations for his excellence. Today, as the Chief Operating Officer of Civil and Structural Engineering Consultants, he brings unparalleled leaderships to our operations. Now, before starting our today's webinar, let me give few announcements to the participants. Please listen carefully. We will be sharing the attendance form, a Google link for attendance. This has to be filled by all the participants to receive the certificates. The certificate link will be at the description, and we will also be posting it on the chat, YouTube chat. Please make sure that you keep an eye out because the Google link is not open now, but it will be open during the webinar, and we will inform you on the chat about the opening of the Google link. When it is open, you can mark your attendance and will be eligible to receive the certificate. I will repeat again, the link will not work until it is opened, and we will inform you when it is. So please keep an eye on the live YouTube chat at that time to mark your attendance. Thank you. Now I would like to hand over the controls to the first to Engineer Retired Air Vice Marshal Udula Wijesinghe to conduct today's webinar.
Good evening, ladies and gentlemen. Today we are going to discuss very important and very interesting topic, that is construction of helipads on rooftops. As far as the construction industry is concerned, there is a huge demand for this special feature. So as a practicing engineers and design engineers, I think this is very important for all of you. Actually, this webinar consists of two parts. The first part will be the information and introduction part. So that will be covered by me. And the most important and interesting part will be the design part and the design consideration part. And that part will be covered by the well-experienced engineer in this subject, Engineer Shiromal Fernando. So, ladies and gentlemen, now let's move into the table of contents of today's webinar. Introduction. What is a helipad? Where can we find the helipads? Why do we need elevated helipads? Challenges of elevated helipads. Type of helicopters. Part of a helicopter. Components of a helipad. layout of helipads, factors to be considered, design costs, design considerations, downwash effects, vibrations, noise, design of helipads, design of FATO, that is final approach and takeoff area, conceptual design of helipads, structural design of helipads, and helicopter downwash. So let's move into the introduction part. When you look at the aviation sector, there are two types of aircrafts available in the aviation sector. That is based on their lift mechanism. The first one we call fixed wing aircraft. So the fixed wing aircraft generate lift through forward motion and fixed wing. To operate fixed wing aircraft, you need runway or airstrips. For an example, from the Sri Lankan point of view, the national carrier, you know the Sri Lankan airline, A320, A330, A340, so on. In addition to that, also you can see from the Air Force inventory, AN-32, C-130, and also the jets also come under this category. That is Kafir, then MiG-27, so on. So other category is rotary wing aircraft. So basically we call helicopters. So helicopter generate lift by rotating their wings in a circular motion. The significant difference is the helicopter can take off and land vertically. So there is no requirement to have an airstrip or runway. It needs only the basically flat platform, obstacle-free area, because it can land vertically and take off and land vertically. So we see what is the definition of the helipad. The area which are designed for helicopters, landing and takeoff, generally marked with the H to help the pilot to easily locate the area. So that is a standard. So generally we mark capital H letter, then easily the pilots can identify the helipad from a reasonable distance. And also the helipads are constructed with generally concrete, asphalt, and steel. Now, gentlemen, we'll see where can we find the helipads. Of course, ground. The ground helicopters are very popular, and also you can find even in the military setup, in the field also. So we will have a clear area. You can see in some grounds also for an emergency situations, we will land and position aircraft. But today we are going to give more details about the rooftop helipads. So other helipads are on offshore helipads, oil stations, and also you can see helidecks also, especially in the ships. And finally on rooftops. So we are going to discuss more detail about the rooftop helipads today. So, ladies and gentlemen, why do we need the elevated helipads? So these are the plus points, mainly the plus points, and most popular. Due to these things, today's construction industry is concerned. These are the rooftop helipads are very popular. Convenience, direct helicopter access to the building, which will be useful to case of emergency situation in VIP transport. If you have a direct access to the building, it's a very good thing, and that is an advantage especially for emergency situation, especially for hospitals and high security zones. This is very important, and also VIP transport because you have a direct access. And also space survey. When you are designing building, the high-rise building in the city limits, you know that the scarcity of the building, the lands, you can use rooftop helipads. The other thing is the security. The maximum security has direct access to the building. As I explained earlier, this is very important. And the plus point is enhance the visibility. Due to the situation of a top of a high elevations provide great visibility of pilots for approach and takeoff. Also, interruption from power lines, vegetations, urban housings are less due to height. So, elevated helipads are generally the helicopter pilots are operate by visually. Instruments flying also there, but commonly they use the visually see and land and take off. So, in that case, the elevated platform is more advantage than the ground helipads. And those are the plus points. And also, the minus points are also there. We call challenges of elevated helipads. Though, of course, the structural challenges, the weight and the vibration during the takeoff and landing. So I am not going to discuss those things because Engineer Shiromal will be discuss those things. And noise and safety concern. Helicopter operations generate considerable loud and noise, which can cause distress to the building and neighborhood occupants. Especially the helicopter startup produce lot of noise. And also because it when take off, they will use the maximum power. And also the landing also, they use the maximum power. So it generate loud noise and it will be a very inconvenience to the occupant of the building as well as the neighborhood. Then other minus point is the airspace restriction. Generally, we construct rooftop helipad in the city. So there is a high security zones also there in Sri Lankan point of view. And also regulatory requirements. They will give some flight path for the approach path and the takeoff path. They will give some directions due to certain reasons. For an example, you can't fly over the parliament and president house. So then pilot has to come in a different direction and approach the helipad. So those are in addition to that, the maintenance requirement also high. Not like ground. The specialized features are engaged in this helipad, rooftop helipad, like fire safety, and the illumination of helipad, and also picketing points. So you have to maintain. I will explain those are in very shortly. This is also very important because when you are designing helipad, you should know what type of aircraft you are going to use for this helipads, because the specifications are different helicopter to helicopter, weight difference, speed difference, and lot of things to be consideration. So then you should have at least some idea about what type of aircrafts available in Sri Lanka and what are the common helicopters. So I will go through the very common helicopters in Sri Lanka at the moment. At present, you can see the Bell 206, the single engine aircraft, we call Jet Ranger also. That is there. And Bell 212 passenger and cargo aircraft, that is again twin engine aircraft. Then Bell 412, again passenger aircraft, and we generally the Air Force will use for VIP flying and casualty evacuation, so on. And also another, this is Mi-17, big large one, the Russian made. This is the cargo helicopter actually, but VIP version also there. So that is about 4 are come under the Air Force inventory. In addition to that, the civil sector also operate some helicopters. So we have to think about that also. That is the Robinson 66 passenger helicopter. This is again single engine aircraft. And Eurocopter helicopters also there. We call Airbus helicopter. So this information you should know, because when you are designing helipad, you should know what is the specification of the helicopter. Otherwise, it's very difficult. Now we'll go to the part of a helicopter. This is also very important because some words we use, some words may be new to you, and I want to refresh your mind before you go to the design sector, design part. then you will be easily understand the Mr. Shiromal's part. These are the basic part of the helicopter. You can see the main rotor is there. So generally main rotor may be 2 blades, 4 blades, or 8 blades, 6 blades, so on. That is depend on the helicopter type. And main rotor is connected to the rotor mast, and the rotor mast is connected to the helicopter main body. So then you can see that there is a place called cockpit. That is the pilots are in that area, and all the operations will be done through that room. That is called cockpit. Then under the fuselage, we call fuselage, the belly, you can say, the body, you can see the landing skids. So all the weight will transfer through this land skids to the helipad. Sometimes you will get landing wheels as well. So that is depend on. As I show you, Mi-17 has wheel, but whereas the 212 has landing skids. So accordingly, you can calculate the weight for your design work. So rear side of the helicopter, we have engine and transmission, basically engine. Then the main body will connected to the special boom called tail boom. The end of the tail boom, you can see the tail rotor. So basically, in Sri Lankan point of view, all the helicopters with main rotor and the tail rotor is there. So that is also very useful, because when you designing, you have to have a safety area. For that requirement, you should know what is the length and the dimension of these details to clear the regulation or approval. Then, gentlemen, will just go through the components of a helipad. Basically, as I mentioned, it's a obstacle-free area, right? For you easy understand, you can see 3 squares. So the outside the square, you can see there is a thing called wind sock. So wind sock is some kind of apparatus to identify the wind direction to pilot, because the takeoff and landing, very important, the wind direction. Generally, you know, the aircraft will be take off, land against the wind. So wind direction is very important. That is generally outside the safety area we install. Then you will have the safety area. The safety area, within the safety area, then you can see another square we call the final approach and takeoff area. So the pilots will approach to this square from a reasonable distance before they touch down. Then inside the final approach and takeoff area, you will have another square that is called touchdown and lift-off area. When the aircraft will approach through final approach, it will come to the touchdown area. And when the takeoff, it will go through the takeoff area. So inside the touchdown and lift-off area, you can see a circle. That is, we call touchdown and positioning circle. So finally, the aircraft will come to this circle, and you can see the letter H, as I mentioned in earlier. The pilots will touch down in this area, and the aircraft will be positioned in this area. Now let's see the layout of a helipad. This is also very important. Basically, as I mentioned, the obstacle-free area. And if you take the overall depth of the helicopter as D, the safety area should be 3D, 3 times the helicopter length. Then inside the safety area, you will get the final approach and touchdown area. That is 2D. Then finally, D, that is overall length of the helicopter, that is the aircraft positioning circle, and letter H also there. So when you are designing the helipad on rooftops, these factors to be considered. These are the main factors. There are some other some factors also available, but these are the main factors to be considered when you are designing helipad on rooftops. The markings, lighting and lighting for night flight operations, then fire safety and ticketing points. The right side of the picture, you can see the Bell 412 aircraft positioned in the former Air Force headquarters building at Slave Island. So we'll go briefly the factors to be considered now. The fire safety. As you know, when the aircraft is start up and the landing and takeoff, it may be very critical when the fire is concerned. So the fire safety is a mandatory requirement as per the regulatory for the aircraft takeoff and landing. Toward this, so we'll introduce generally for rooftop helicopters, we introduce fire extinguishers, the fixed fire extinguishers for that. You can see that is actual one, the former Air Force headquarters, again, we captured from there. And also some areas to operate the firefighters, other equipment. So that is also to be considered. And also not in Sri Lanka, but other countries, they use the sprinkler systems for the helipads. Bit expensive, but now it is commonly we use. Then ticketing point. As you know, sometimes the aircraft may come and touch down the rooftop helipad and again take off. But sometimes we have to keep the helicopters for a certain time, maybe due to some snack, some security reasons, or whatever. So in that case, you will keep the position your helicopter in the rooftop, and it's very critical due to winds. So in that case, you have to have a ticketing points, because if the turbulence situations, the aircraft will be moved, and sometimes the bad effect can be expected due to high winds. So in that case, you have to anchor your aircraft to the ground, to the helipad. So this requirement, the manufacturer will give the layout of the ticketing points arrangement according to the aircraft, because you can't anchor the aircraft as you want, because some hard points are available in the helicopters, or sometimes some only the fiberglass and the plastic, very soft material parts are there. So you have to identify the hard points, and according to the hard points, they will give the ticketing point arrangement. The ticketing points are basically the anchoring point. So any aircraft you design for helipads, you have to refer the manufacturer specification for ticketing points specifications and the ticketing points layout. That is very important. But you can review and you can get the permission from them, and you can even if you think about this is not enough, you can write to them and you can get additional ticketing points for your requirement. Another thing is there is the markings. The marking also very important. So this is the regulatory requirement. You have to mark the helipad as per the regulatory requirements. So these are the basic markings. The helipad name is, you can see the any color, ICAO. For an example, this is indicate ICAO. Then you can see touchdown and land off area marking. Generally white line with 30 centimeter wide. Then maximum allowable mass. You know the all-up weight. That is the maximum allowable. All-up weight means the fuel, aircraft weight, then the passenger and cargo weight including. That is the maximum weight you can land on the rooftop. Because as a design engineer, we should know we are going to design below this. In this case, less than 6 tons. Then helipad identification marking in white H, because then easily the pilots can identify the helipad from a reasonable distance. Then touchdown and lift off area perimeter lights also there, that is for night flight operations. Then touchdown marking in yellow circle, that is the final the aircraft positioning area. and touchdown light and lift-off area also there. That is again floodlights for night plane operation. In addition to that, you have to have some obstacle lights and obstacle marking. If there is obstacles, you have to mark and you have to indicate the obstacle lights in the vicinity of your helipad. Maybe tall buildings, towers, etc. Accordingly, you will have a red light. And then the pilot know the power lines and other obstacles. So night lighting. This is also very important. Sometimes you have to land in the night. The night plane operation, you should have some illumination system. So in that case, we use generally heliport beacon. So in the night, you can switch on the beacon, then the pilot can easily approach the helipad and identify the helipad from a reasonable distance. Then illuminated windsock. So you can't, as I mentioned, the windsock also is a very important instrument for the landing and takeoff. So for the night plane, you have to have illuminated windsock there. Then helicopter approach path indicator, HAPI. So that is for instrument flying. So sometimes, though I say the pilots are visually operate the helicopter, sometimes you can buy we call sometimes autopilot or something like that. Then the approach path indicators are very important. So according to that lights, the pilots can approach the helipad without any problem. Because like sometimes with the winds, maybe in the mist, with that floodlights, pilots can easily approach the helipad. Then final approach and takeoff area and touchdown and lift-off area indicating lights. You can see that green light, then the amber lights also there. So that is the final approach light systems, final approach and takeoff area lights, and touchdown and lift-off area. So there's a small video also there. So how the pilot can land in the night with the indication light. So these are the standard codes for construction of helipads. So as you know, we have to follow certain guidelines and regulations when you are designing helipads. So generally, we use International Civil Aviation Organization, we call ICAO standards. ICAO Annex 14, Volume 2, that is mandatory. You should follow that codes when you are designing helipads. And the Federal Aviation Administration FAA standards, USA, FAA Advisory Circular 150-5390-2B, helipad design, that is specially for heliport design, that is number of helipads. Heliport means number of helipads, maybe 2 or more. We call heliport, but helipad means single. Then European Union standard, European Union Aviation Safety Agency, CS HEL. Then National Fire Protection Association, NFPA 418, standard for heliports again, and International Organization for Standardization of, that is ISO, British Standard BS 6165, BS 8110 Part 1, Code of Practice for Design and Construction, BS 6399 Part 1, Code of Practice of Dead and Impost Loads, BS 5950 Part 1, Code of Practice for Design and roll and welded section. In addition to that, you can use other design codes also, and also you have to follow the civil aviation regulations, and also you have to get some information from the Air Force as well when you are designing helipads in Sri Lanka. With that, I will come to my end of my part. And now I will respectfully invite well experienced in this subject, Engineer Shiromal Fernando to continue the webinar. Over to you, sir.
Thank you, Engineer Udula, for a very interesting and informative introduction and his experience on in Air Force with respect to these helicopters. I think audience got a good idea about the main concept of designing helipad. So basically, my task is to talk about the structural design. So basically, structural engineers always look at the most possible events, like what will happen with respect to vibration, noise, then impact on people, impact on cladding, air quality, like always the worst case scenario. You always look at the worst case scenario. And then how to make people's life safe. So basically, in a helicopter, there will be noise, and it's a very pilot should be very experienced person to operate. So it is a very small area. So when the helicopter approached, because of the rotor turning, so there is a down flash. So basically, it is much more than the wind-induced down flash. It is a force down flash. So because of that, we have a pressure on the slab and also the surrounding areas, right? So therefore there can be many disasters. The people can be blown off if they are not in the safe areas, and then the cladding can be blown off. Any loose particles not fixed can be blown off, right? So there are so many things that we need to look at when we are designing with respect to structures. Now, say for instance, if we design the cladding for the wind blow, if we design if there is a helipad, the top part, due to the down flash, we will have a very high wind pressures at the top facades. So maybe if you design based on the BS standards, you might get a pressure about 2 kilonewton per meter square, but actually due to the down flash, we can get about 5 to 10 kilonewton meter square wind pressure in the top part of the cladding. So we need to understand that areas, and also with the spread can go up to 200 feet, right? So it is so effect that we have to consider can be around 200 feet radius. So this is very important to understand. So all the structures within that area we need to look at. So also side wash is also another issue where people can get affected if we are very close to this side. So people should not go very close to the helipad until it is totally shut down. So so down if inform raise awareness of people, the vicinity. So basically prevent people from entering the helicopter, the approach path, canopies and open spaces has to be very well designed. So all these forces has to be taken into account for And also sometimes the helicopter can rotate, right? So it can give vibration to the building. Generally, the vibration is frequency of vibration is rotor speed into number of blades. Mr. Udula told it can be 2, 3, or 4 blades. So based on that, you can estimate the frequency. If that frequency matches your slab frequency, then it will go into resonance, right? So we need to make sure that doesn't happen. So here, so although now say we have a structure of helicopter, we cannot design only the we cannot assume only helicopter will land only at this H symbol. It can go up to the edge. So you need to consider all possibilities when you are designing the helicopter, right? So it is not in a particular place, right? So your bending moment, shear force, you have to keep get all the critical locations and look at all the possibilities that it can happen. So basically, you can calculate the flow vibration in the analysis, and then you can calculate the damping and also the frequency, natural frequency of this thing, and make sure the rotary frequencies are not matching this frequency. If that happens, you have to have a tune mass damper to mitigate the damp the vibration. As Mr. Udula's presentation, there can be a separate. Now you can have a concrete one that is what easy. You can also have a structure above the slab, where if that is the case, you need to isolate that vibration transfer into the slab. So you can have neoprene pads, springs to isolate that vibration to the building, like a bridge. So basically, the noise is another issue. It is not directly structural, but it is also need to be catered. Basically, if it becomes a nuisance, the occupants under the building will complain. Let's say you have office or something like that under, if the helicopters are coming, and then if it becomes a noise, then you have to treat your glass, make sure that you have the insulation by glass insulation that reduce the noise gain into the building, right? So that is also another aspect that we need to consider. So you can do a full range analysis while considering the approach and takeoff, and examine the noise levels by using simulations, and try to understand what kind of noise is going to transmit to the building, right? So and air pollution is another issue that we get, especially at the ground level. But in the upper level also, there's a possibility of air pollution. If that is the case, and most of the time it produces the noxes and monoxides, which is hazardous to us. And if that is the case, we need to take action so that this will not get into the building. Right. So when you design this this helipad, so you, as Engineer Udula said, we have the taking and lift off area, then the approach and taking off areas, and the safety areas. So basically, you need to calculate the load bearing capacity of the slab in these areas and then provide the reinforcement. So basically, now say for instance, the helicopter can be around 10 meters, then your takeoff approach area will be around 20 meters, and then you have to have a safety area another 10 meters. So basically, your helipad will be around 30 meters by 30 meters, right? So it is like total building. Generally, building is around 25 to 25 meters. Right? So 30 meters means the total building area you need to have for this. So it should be clear. There cannot be any obstacles or lift water tanks or anything like that. Okay? It should be above all. And then there should be staircases to people to go down. If there is a hospital, you need to have lifts to take the people down. So likewise, right? It should be clear 30 meter by 30 meter if based on the helicopters that you look at. So generally, if I can remember, it's around 10 meters. So basically, as I said, the final approach and takeoff area, and then the lift-off area, and the so basically, when the helicopter reach and touch, then it is not only producing a static load, but is also producing a dynamic load, right? So when it comes, normally if it comes, it will the speed that is coming and landing is around 1.8 meters per second. So it is like if you're traveling in a lift, 10-story building, it is the kind of moment that you get. In case of an accidental this thing, it will be around 3.6 meters per second, right? So that is almost double. So we need to think all that in our factors, right? So dynamic factors, so that the both possibilities there. So 3.6 meters is, if you go in like World Trade Center, the lift speed is 3.5 meters. So that is the kind of speed that it can come in an accidental mode, right? So basically, of course, the structural engineers are working with unknown forces, unknown loads. So obviously, we put safety factors, right? So in order to cater all these loads, ICAO, that is the International Aviation Organization who has recommended these values, is for ultimate design, you have to have a 2.5 safety factor. Live load, of course, we use 1.6, dead load 1.4, wind load 1.4, right? So there are two cases that we normally design for superimposed dead load. Design for load for helicopter landing area. And then other one is the superimposed load case B is helicopter at rest. So when it approach that area, we have to have this a particular superimposed dead load. And then for the helicopter at rest, we have the case B. So basically, so LH means the weight of the or mass of the helicopter, and then because there can be a resonance, there is another factor called resonance factor for the load. So basically, you have 2.5 meter dynamic factor, and then you have the mass of the helicopter is around 13 tons. Let's say 10 to 15 tons based on the helicopter. And you can get, there are charts to get what is the helicopter, that maximum helicopter that you generally you design for the maximum one available in the country. And then possible price that can come to the the helicopter area. And then you have an additional dynamic factor called. So generally the dynamic factor is around 1.3. So you multiply by 2 factors. And lateral load, again, now when the helicopter moves, there is a lateral traction load where you have is considered as half of the weight of the the helicopter, right, into the safety factor. So overall, superimposed dead load can have is around 1.5 times the most superimposed load, generally 0.5 kilonewton per meter square. And dead load is around, dead load, you have to take into that. And wind load, obviously, we can calculate the wind load based on the wind tunnel data, or you can use the code to calculate the wind tunnel. So for the punching shear, sometimes you can have the skids and also the tires. So basically, the minimum area they have specified is 64.5 into 10 to the power 2 square millimeters, right? So that is the area that we need to look at for tires or skids. So basically, the load you calculate and then you divide by the area. That is the pressure that is going to come onto the list. Then helicopter at rest, and at rest you can it is not dynamic, so you just calculate the area, the load, the self weight, multiply by the factor. And you can also for the superimposed load, there's a possible load that is coming onto the slab. Minimum you have to consider 0.5 kilonewton per meter square. So shear check as appropriate, we normally do the shear check similar to that. So basically, these are the loads for different categories of helicopters. It can go up to 27 tons. But basically, I checked with Engineer Udula, it's the maximum available is around 13 tons bale helicopters. Am I correct? Yeah. So basically, so you have this superimposed loads, superimposed loads given in this chart. You can use those values to calculate. So this is a case study we did. The one Tower C, they wanted a helipad. So basically we check, we used 500 millimeter thick slab for the building, and then this is the typical calculations that we have used for the based on the ICAO standards. And if you look at these are it is around like 10 to 15 kilonewton per meter square static load. So these are the typical calculations you can have, as I explained. So this is the case B when the helicopter at rest. So the design load, static load is here we have used 11-ton helicopter where the static load is 17 kilonewton, overall superimposed load 0.7, dead load 1.4 kilonewton, and then wind load is 1.4 kilonewton. So what you normally do is we analyze the slab. So you can see it is situated on top of the core, and then you put the loads, and then we look at the deflections at service load case A, case B, and also you place the helicopter at different areas and see what is the worst scenario. And then you calculate the bending moments, M11, M22, case A, case B at different combinations. And finally, you calculate the shear forces. Again, you look at the worst scenario and try to calculate the shear forces. And then we provide the reinforcement, right? So, and also you can see the shear force or shear links are being provided throughout the slab. So make sure that there won't be a shear failure in the slab because there are so many scenarios. So thank you very much. We like to thank Professor Mendes, Anisha Pereira, who has done a lot of work behind the scene, and Udaya Indika also, and the CSC team who has worked on this project. Thank you.
Thank you, Engineer Shiromal Fernando and Engineer Retired Air Vice Marshal Udula Wijesinghe for that very informative session on helipad construction on rooftops, explaining us on the importance, challenges, and design in construction of construction on helipads on rooftops. So now, before winding up, we would like to open the floor for the Q&A session. Participants, if you have any questions regarding the webinar today, you can drop your questions in the YouTube live chat. We will direct your questions to the resource person. We have one question, sir. This is for I think, Engineer Vice Marshal Udula Wijesinghe. In a blackout situation where you have no power, is there any power backup that is maintained at helipads for night landings?
Very good and very interesting questions. So generally we use a standby power supply to the helipads, or else we use we call goosenecks. So you can light up kerosene lamps for the night flight.
We will share the Google Form link now in our in the YouTube chat. You can, it is also on the YouTube description as well. We will be opening the attendance link for everyone. So you can mark your attendance. And meanwhile, if we have any more questions, please feel free to drop your questions in the chat box. We will give you 1 to 2 minutes.
Yeah, how much we have, but actually in practice much more than that. So we have given an area. So the load you have to divide by the area, that is the area that we have.
We have one more question. if the rooftop is very wide and we could incorporate post-tensioning on the slab, how would vibration affect the ducts on the long-term scenario? Would it affect creep and shrinkage of the concrete?
Now, it can be a post-tensioned slab. That's no issue because it's but the creep and shrinkage that you talk is about it is for the long-term loading. So basically, it is not a long-term loading. It is an incident load. So there won't be a major consideration on the creep and shrinkage. Basically, creep and shrinkage will or anyway happen based on the sustained load. That is not relevant to the helipad landing. So, but there is no problem using post-tension in the helipads.
There's one more question, sir. As a designing student, how to protect an offshore building?
Offshore building. Offshore, now there are different offshore structures where you have offshore structures. The loading is due to the waves. So basically, you need retaining structures to support the offshore structures. So and on those structures only we will try to build the structure. So that is what the answer. I think. Are you referring to a helipad, offshore helipad? Yeah, yeah. So basically, if it is like a oil refine, so this is also a normal structure with respect to oil refinery. Basically, you try to design for the lateral loads from the sea waves for the foundations, but the top slab will be is the same as other slabs.
How about the approach in steel structure instead of reinforced concrete structure?
That is a good question. So it can be steel, or you can have even structured aluminium for the approach slab. So basically, let's say if the structure is cantilevering like Burj Dubai, so you have to have a steel structure. So if it is concrete, it is good because it has a big mass, so the vibration is less. So if it is a steel structure, the vibration may be the major issue. Then you need to isolate the vibration from the main structure. So so that is the only thing. So basically, you can have a steel structure which is isolated from this thing. So you have to have isolation pads, and then you have to design the steel structure for the loads that I have spoken about in the. So the steel structures are not a major issue. Steel structures is a mandatory if it is cantilevering from outside the building. Yeah, fire protection is also very important. Anyway, you need to have fire protection for all the buildings, but for steel, fire protection and the corrosion protections is to be done.
In case of failure in landing, is there any measures that will be taken to prevent any damages or destructions to the building?
No, actually, as Engineer Shiromal mentioned, so we have to design the roof slabs for the worst case. Sometimes you may, especially for the single engine aircraft, it may fail and it will come like with the gravity. So in that case, we have to design. So we generally design for the worst case. So we know the weight and the velocity. So accordingly, we can analyze the worst case, then we can design and accordingly to the punching shear. But for the safety area, there is a regulation, so it should be an obstacle-free area. As I mentioned, that is 3D. Beyond the 3D level, you can, but otherwise you can't have any obstacles. The fence wall like that. So that's depend on the pilot's capability. So generally, the pilots can approach easily to that if there's no engine failure. Pardon? The rooftop helipad. So generally, we designed the helipad for rooftop for the easy access, no, and also sometimes due to some snag or unserviceability, you have to keep the helicopter. Otherwise, we will never keep the helicopter in the rooftops. It's very difficult, and you have to anchor the helicopter to the rooftop. That's why I explained the picketing points are there. But if there is unserviceability, we have to keep the helicopter for 1 or 2 days. In that case, you have to tie down the helicopter to the slab. You can't have a guard walls because that is always dangerous. And according to the regulations, it should be an obstacle-free area. And especially the two rotors are operating, and the tail rotor is very harmful. If so, that is the case.
So these questions, I think you can answer this one as well. What is the latest high-rise building helipad in Sri Lanka? And also any prominent direction to keep the H symbol on top of the helipad? Any prominent direction to keep the H symbol on the helipad?
Yeah, the H symbol generally the approach path. Generally you have sometimes you have to get the approval from the civil aviation sector, because sometimes your buildings may be in the high security zone. Then you have to change your approach path as well. So generally we keep the H as a approach path and takeoff path. That is the yes, the Air Force headquarters has the helipad. Tallest building. No, I don't have any idea about the. No. So yeah, that is the 40-story building. The Air Force, the former Air Force headquarters.
How do you check the pull-out of the picketing points mentioned? Is there any special detailing or special considerations during fixing or casting the picketing points?
So actually, the picketing points will be based on the manufacturer's specification. So actually, I think they have done their test and they will give the specification, the rings, dimensions, then the anchorage length, and how to anchor. But I don't have any idea about the test. During construction, we can do the yes.
Any additional safety arrangements for the structure beneath the helipad for any falling objects, or in worst case, a helicopter? Or we can go for any additional safety arrangements for the structure beneath the helipad for any falling objects, or in worst case, a helicopter?
No.
We move on to the next question. What are the codes related to the fire protection in helipad designs?
We not
Yes, it is. We have discussed this, the codes in the presentation as well. So you can rewatch the webinar when we post it and get the codes from that. And the last question, when considering landing area, when modeling, placing the helicopter load should be in the circle or anywhere on the slab?
As I mentioned earlier, I mean, the landing area will be the most critical area, but if the landing area is not in a there are unsupported areas possible if the landing due to the crash landing or something like that. Those areas also you need to put your loads and see whether there is a issue with respect to bending, shear, or um, or torsion or something like that. So basically, so generally the critical area is the landing area. If they land properly, if they missed, then you have to look at the other areas too.
With that, we will conclude the Q&A session, and thank you, engineers, again for answering the questions of the participants, clearing out all their doubts. And now we would like to wind up this session with reminding about our upcoming course, which is the computer-aided analysis with Procon. This will be starting on 5th of March and will be conducted for 4 consecutive Wednesdays from 7 p.m. to 9 p.m. All the registration links are on our social media platforms. You can register through those links. And if you are interested in our future upcoming webinars, courses, or seminars, you can contact us and get updates through our social media platforms, our email, WhatsApp channel, LinkedIn, Facebook pages. And now with that, finally, I would like to thank all the participants today who joined with us for this webinar. With that, I would like to conclude the session for today, and thank you all for joining. We will see you at our next webinar. Thank you. Thank you.